For this video, we are going to find the area of a trapezoid. So first, let's know what a trapezoid is. Okay, so area of a trapezoid. I typically start out in wide. The area of a trapezoid. Okay. So first, let's figure out exactly what a trapezoid is. Okay. So in the last video, we talked about parallelograms, which was just the top piece of a rectangle slid over a bit. Okay, and it keeps the top sides parallel to that side, and the left side's parallel to the right side. Well, what a trapezoid is simply one of these things are not parallel. So this top side, the top is parallel to the bottom, but it's not as long. So it just goes to there. So then we have a figure that looks like this in blue. Okay? So we no longer have a parallelogram because this side over here on the right is not parallel to that side. And so really you can think of a trapezoid as a parallelogram that's been distorted a little bit, and you're no longer parallel. Okay? So that being said, let me erase that, and let's just draw an arbitrary trapezoid here. So let's go here, and we want to stay parallel on top, but not as long. That's what's going to make it a trapezoid, because it's going to force these two sides to not be parallel. Okay, and we want to talk about the area of this thing. For this, talking about the area, let's call this bottom piece, let's call it base 1, and call the top piece, call it a base 2. Okay, and just to see where this formula come from, because it looks kind of confusing, and I always like to try to make things make sense. And if you've watched the last few videos, I think you can get this. So just quickly here, if I split this trapezoid in two, I see that I have two triangles, and we have some height here of h is the height, so that is h, and it is the height of the bottom triangle. But know that it's also, if you gotta have a little imagination here, it's also the height from base 2 to the top of that triangle. So that height h there is the height of both of those triangles. So the area of this trapezoid, we can see here, the area of this trapezoid is going to equal to the area of these two triangles, the sum. So the area of the bottom triangle here is going to be 1/2 base times height, 1/2 b1 times height, plus the area of the top triangle, this one. It's going to be 1/2 its base, call that b2, times the height. And if we use our distributive property and factor out the h, what do we get? H times 1/2 b1 plus 1/2 b2. This equals h times, and this base 1, you always think when you're multiplying a fraction times a number, a fraction times some whole number, think of it as b1 over 1. That's b2 over 1. And you just multiply straight across. 1 times b1 is b1 over 2. plus 1 times b1, or b2 is b2 over 2. And 2 times 1 is 2. So now we have common denominators of 2 and 2, so we can add. So equals h times b1 plus b2 over 2. Okay, so that is the definition of the area, or the formula for the area of a trapezoid. Let's talk through that one more time and make sure I believe you can do this. Let me go in yellow here. So the first thing we do, first we call this piece base 1, that piece base 2. When we look at this height here, call that the height of the bottom triangle, but if you notice, it's the height from base 2 to the top of the upper triangle too. So we see that this trapezoid is simply the if we can find the area of those two triangles and add them together, we get the area of a trapezoid. So we take, for the bottom triangle here, we take 1/2 base 1 times height, plus for the top triangle, we take 1/2 base 2 times height. And then we have common factor here of h, so I can pull that out. Remember, the distributive property will sending it back in will give me what I had before. So we pull the h out, and we're left with 1/2 times b1 plus 1/2 times b2, and 1/2 times b1 resulted in b1 over 2, 1/2 times b2 resulted in b2 over 2. And now we have the common denominators. We can add our numerators and get the area of the trapezoid is b1 plus b2 divided by 2 times the height h. So let's say that our base 1 here is 5, and let's say that base 2 is 3. So our height equals 2. So to find the area here, given that information, we have area equals h, which is 2, and let's say it's 2 inches. And b1 is 5 inches, plus b2 is 3 inches divided by 2. Alright, so we get the area equals 2 inches times, and note 5 inches plus 3 inches, we're not multiplying there, so it's not squared inches yet. That's just 5 inches plus 3 inches gives me 8 inches. 8 inches divided by 2. And this is going to give me, that's going to be the WAF calling again. Math department. Hey, I'm right in the middle of a podcast. Can I call you back when I'm done? We're talking about trapezoids, the area. Hey, I'm actually in the middle. You're being recorded right now. Love you. Well, okay, she was okay with that. So this is going to give me 2 inches. And the 2 goes into the 8 divided by 2 is 4 times 4 inches. And now I have 2 times 4 is 8. Inches times inches is square inches. Okay, so our area is always going to be square inches. Again, let's say what that means. That means that in this trapezoid here, with a base of 3, a base of 5, and a height of 2, we can fit 8 1-inch by 1-inch blocks. I mean, that's what area is. That this is a square, this is a square inch. And to say that the area of this trapezoid is 8 square inches means that 8 of those will fit in there. And that will do it for the definition of the area of a trapezoid.